Our information item today is item 6, presentation on rethinking power generation. And one of the initiatives I've pushed as chair for this committee is to bring guest speakers at our monthly meeting to share details about technology and projects we have funded or partnered with. And over the past few, we've heard innovative technology projects such as the Joint Electric Truck Scaling Initiative, or JETC pilot project, an e-trailer system being utilized as a component in the electrification of heavy-duty fleets. We've also heard from the ports about technological advances. We've also recently heard from Mindspring about their linear generator technology projects for fleets. Today, I'm excited to welcome and continue our exploration of strategies to generate power when the grid is not available or ready to support a project through cutting-edge linear generator technology for multiple applications. I'm pleased to introduce our guest speaker, Bobby K. Shirian, Senior Vice President for Government Affairs for Helion. Welcome.
Thank you very much. I appreciate you all giving us an opportunity to share with you what we're doing at Helion today. And I'm hoping by the end of the presentation, you'll be as excited about this project and this product as we are as we go forward into our commercialization. Just briefly, on the right-hand side of the screen, you see one of our power generation boxes. We call it the Carno Power Module. You'll see it's got a great form factor. That is our 200 kilowatt launch product that we're just commercializing here this year. If we go to the next slide, please. Tell you a little bit about Helion. We are an Austin, Texas-based headquarters location. It's also where our manufacturing is taking place. We also have an R&D facility right outside of Cincinnati. And the reason why Cincinnati is important is we actually acquired this Carno technology from GE a couple of years ago. So GE was the original founder. We acquired that entire technology, the IP, as well as all the founding engineers that were part of this technology as well. On the right-hand side of the screen, you see a couple of depictions of what the system looks like in a much larger form factor, and I'll share with you a little bit more details about how the system actually works and what we are actually trying to bring to market right now. Next slide. From an applications perspective, we have very wide spaces that we can play in. On the defense side of our applications, we have several that we're in the middle of working on right now. The one that is very public today is with the Navy. We are actually producing a power generation set that's going to be used in autonomous vessels going forward. Some of the benefits of that are we can use liquid fuels in this application. It's very low maintenance from a maintenance perspective. So when you have nobody on board the vessel to do any kind of work, this is a great fit for autonomous platforms. We're also working with the Air Force on flex fuel power generation, working with the Army on some really unique systems as well. So from a defense perspective, we see a really good opportunity. Data centers obviously just don't have enough power today. And so this is a great fit for the technology where we also have the ability to be completely fuel agnostic, provide great backup solutions, as well as prime power applications. From a waste gas perspective, think about oil fields and landfills where you have methane gases that are being flared off into the environment. We can actually take those flare gases before they're processed, before they're cleaned, and actually run them through the generator and produce electricity from what would normally have just been a waste product. Prime power is a great place for us as well. So if you think about warehouses, distribution centers, Home Depots, Walmarts, we can be the entire power source for all of those facilities. And then lastly, EV charging is a great place for us. Some of our customers are going to actually be using the Carno Power Modules in EV charging applications. Next slide. Okay, so if we talk a little bit about how the generator actually works. So this is very different than any other type of generator system that's out there today. The two ends of the system where you see in orange are the places where we actually bring in fuel. And we spark that fuel one time to actually begin to just extract the heat. So the way I want you to think about this generator is our only input to produce electricity is heat. That entire center section inside of the orange is actually hermetically sealed to what fuel is coming in. It does not know what the environment looks like. The only thing the actual power system is trying to check for is if it has enough heat to actually produce electricity. So if we go to the next slide, you'll see a little bit of an animation how the system actually works. We only have one moving part in each of these shafts to produce electricity. So remember that center section where that piston is actually moving is completely hermetically sealed. So what we do is we'll bring in a fuel on both sides of the system. And if we start on the left side first, bring in a fuel, we spark that one time just to be able to get the burning process to start on that fuel. And think about it as if you're at home in your stovetop and you're running a natural gas stovetop, it's just burning. It's just kind of oxidizing that fuel. The only thing we're trying to do, though, is extract the heat from that fuel. So we're not using any internal combustion practices. We're just doing a slow burn on that fuel to be able to draw the heat out. And through a series of heat exchangers, we bring that heat into that red area of the system. That red area is really just a trapped volume of helium. So as that helium starts to expand, it pushes the piston to the right. And on the other side of the generator, or the shaft, I should say, we have the exact same reaction that's happening. The fuel is coming in. It is heating up the helium on that side of the system and pushing that piston then the other way. It's going slow in the video that you see here, but 20 to 30 times per second, that piston is flying back and forth across a series of magnets and coils and producing electricity. We are 800 volts DC natively coming out of the system. If we go to the next slide. So this is just a quick depiction of what the system looks like on the inside of that box I showed you on the first slide. So there are 4 shafts in our base product that will produce 200 kilowatts of power. If we hit the next slide. So from a benefits perspective, you'll remember I said that the system, the power system itself in that center of the generator is completely hermetically sealed. So it does not know what fuel is actually coming in. So we are completely fuel agnostic. We can use gaseous fuels, we can use liquid fuels, we can blend fuels together on the fly, hot swap them. So we bring a lot of versatility, a lot of reliability when it comes to electricity production. Our efficiency levels are also very high at 50%, significantly higher than you would see with traditional generator solutions. And as you had seen in that video earlier, there's only one moving part in each of these shafts. So our maintenance is also expected to be very low. There are no oils to change. We don't use after treatment systems at all in the solution. Very quiet as well. So oftentimes when the system is running at full power, your conversation you're having with somebody will actually be louder than what the system will be in application. Ultra low emissions as well. So you'll see here we're single digits, NOx and carbon monoxide, natively coming out of the system with no after treatment systems that are involved. If we go to the next slide. So I wanted to tell you a little bit about what the form factors of our systems are as well. It's very unique, nothing quite like it in the industry today. So our 200 kilowatt launch product that we're commercializing this year can fit in a small area of about 8.5 feet in length, 8.5 feet in height, and about roughly 3 feet in width. So very, very small from a form factor perspective. Our 2 megawatt solution, and think about this for data center type applications, roughly in the size of a 20-foot shipping container. So very, very power dense, not a lot of real estate required to get to very large scales of power. If we go to the next slide. The way that we unlock this type of technology, there's really nothing else like it, is we use additive manufacturing or 3D printing. So if you were ever able to come to one of our facilities, you'll see that we have a fleet of 3D printers that are printing really, really unique shapes. The shape that you see here, the part that you see here on the upper left-hand corner of this page is actually one of the parts that goes in the generator. You'll see these very narrow flow channels that we are utilizing and very highly complex components that we use for heat exchange within the system. If we go to the next slide. And this is my last slide, telling you a little bit about where we are in terms of our commercialization process. You saw earlier that we are playing heavily in the defense space. We've delivered the first 2 units as an early adopter customer to the Navy. Remember, this is ultimately going to be used in an unmanned vessel application. We also have 2 additional systems that we're working on right now. One of those is going to be for certification purposes with UL, and the next one is going to be for our first commercial customer that is going to be utilizing this system for power applications later this year. And that is my last slide. I'd love to take any questions that you have about the system.
Well, thank you. It's exciting to see what you're working on and the different applications. Do we have any questions? We'll start with the supervisor, then go to the mayor.
Thank you.
Yeah,
Really appreciate the presentation. I'm wondering as, early stages, but when it's deployed, how's it, also go back to operational costs. How does it look for, competitive with current energy rates and those type of things? And how's your ROI on that?
Yeah, great question. So we haven't been public with a lot of those details. I'll share with you some examples, though, that should be able to frame it a little bit. So from an upfront cost perspective, we expect that we're going to be less than a fuel cell. Traditional generators such as natural gas and diesel, we're probably going to be a little bit higher than those systems. Where we see the benefit, though, is we will more than make that up with the actual operations cost of the system. In most places, we're going to be less than the grid. And because our efficiencies are so high compared to some of the traditional technology and generator areas, we expect over the long haul that our system will actually be more cost effective than some of the technologies that are in the market today.
Thank you.
Okay, Mayor McCallum.
Thank you very much. How fast does the thing start up?
Great
Transferring
question.
heat?
Yeah, great question. So if we go from a black start, complete black start, roughly within 30 seconds, we're at positive power. And then between 3 and 4 minutes, we'll actually be at full power.
Thank you.
You had a slide earlier on as far as the different applications.
Yes.
Can we go back to that slide real quick? Oh, thank you. So can you share any examples of where you're utilizing these applications currently, or that you can report on that are in the works?
Yeah, we haven't really been public yet because we're just now getting some of these systems out today. So the ones that we have talked about publicly so far is the Navy has delivered, or we've delivered to the Navy the first couple of units that they're going to be using in testing to ultimately put these systems into unmanned vessels. We have a couple of customer commercial units that are going to be coming after that. Can't name those customers yet. The plan, though, is going to be using those in EV charging and other stationary type applications. Over the course of the next several weeks and months, we'll start to be more open about what those applications are, but I would say those are the early ones that are going to be coming.
Okay. And then just from a regulatory standpoint, are there any barriers or challenges that need to be worked through?
Yeah.
Just things that within the scope of even AQMD that we're working on with you that can demonstrate future collaboration.
Yes, great question. So we've actually already been working with the AQMD team around the 1110.3 regulation for linear generators. So in that regulation, there are certain thresholds set for emissions, and we feel very comfortable that we'll be able to achieve those levels. In addition to that, just recently, EPA has also weighed in on the technology and indicated that we are not going to be considered an internal combustion engine as it relates to regulations at the federal level as well. So as we see going forward how our implementations will work, it's going to really be dependent on local rules and local permitting requirements. So we feel like we've got a really good path to success there as well.
And do you see potential utilizing this technology and working with the public sector in areas of service such as wastewater treatment facilities, water districts, other high energy, high capacity need functions that need to have that reliability, but just with increased capacity constraints where you could step in and see these generators used? Can you share a little bit about your vision in that space?
Yeah, absolutely. I think the answer is yes. So as we see it today, we are not restricting ourselves to any particular area. We see a lot of pull from certain places, absolutely. If you think about data centers and what we're doing with the defense side of the business today, but absolutely, wastewater could be a really interesting place for us to participate in, and absolutely we'll look at that.
There's been a lot of discussion about the ports in recent days. What can you say about the role linear generators can play in the overall need for infrastructure and capacity in that space?
So we've actually had a lot of discussions with the ports along the way. Hyliion actually got our start in electrifying heavy duty trucks. And so we spent a lot of time talking to the fleets that were in the ports, especially here in California. And so I think there is a tremendous amount of opportunity, not just for solutions to drive infrastructure, but look at new technologies like linear generators. Ports are a perfect place, especially where we know that there's a lot of emission sitting in those areas, and we can do something about it right away. I think ports are a great application.
How do you describe the relationship with your company and looking to implement your technology and coordination with the utilities?
Yeah.
So Cal Edison, PG&E, describe a little bit of that.
Great
interplay,
question. Yeah.
As far as being viewed as collaborative, not necessarily a competitor or at odds. What is your view on that?
Yeah, great question. I think our goal is to work collaboratively with whoever the customer may be. That does include utilities as well. So as far as we see it, we are here to do business and be able to solve problems when it comes to power, and absolutely want to partner with the utilities, whether it's the utility that's going to provide the fuel coming into the system, or if it's the electricity producer, to be able to integrate our systems within their systems for grid reliability and other microgrid solutions. We see that as a great place for the Carno solution.
Just one other question. I'm aware of, for lack of a better word, a competitor, and they've utilized the linear generators in a residential development context up north, I believe. So what can you say about the horizon of that use of linear generators in that space of using capacity for needs for new residential development?
Yeah, great question. So from a Hyliion perspective, we're focused on our 200 kilowatt power solution, get that out the door. From a residential perspective, we have also talked about having a smaller system that can be used outside of a home, not in the case of backup solutions like you would see as a Generac system, but as a primary power solution. That is on our roadmap, and it's going to be down the road before we get to that point. But being able to do community type microgrids, that's a very interesting space. And I think that can be something that we can roll out with this 200 kilowatt solution. But a single unit home, definitely something we're talking about, but it's going to be years down the road.
Well, thank you. Once you have some of these projects you can go public with, we'd love to have you back next year. Maybe let us know in 6 months how things are progressing.
Absolutely.
And love to hear about further advancements in the use of this technology. Were there any other questions, Supervisor and the Mayor?
Just to follow up on some of the other information on the fuel source. I know it's agnostic, but let's say you have natural gas at the facility already. What size of line, what kind of volume? Does it take the regular size you have, or do you upscale the infrastructure on that as well?
I'd like to come back to you and be very specific with that point, but in most cases, our customers are just using pipeline natural gas, for example, to be able to
So they don't
supply.
have to put new infrastructure,
That's right.
upsize that in general cases. Great.
Thank you, Supervisor. Mayor?
Thank you very much. I'm a huge fan of linear generators and their application in microgrid systems. I am concerned about the startup time, especially for backup generation for data centers. To have 4 minutes to have full power would be problematic. Some way. But I'm glad to see the technology. I encourage it. I just think we need to provide energy options for people when the electric companies are unable to provide it for a considerable length of time, apparently, in getting infrastructure in. So if these are available reasonable time and we can have them on a microgrid, I'm all for it.
Thank you.
Thank you, Mayor. Any other comments, questions?
Just thank you. Thank you for bringing the presentation, to all involved in scheduling, you coming before us, something to be excited about and pay attention to. So thank you.
Thank you very much.
Okay, and staff, do we need a public comment? Yes, we do. So we'll just hang tight for that. Do we
We
have any?
do. We have
Oh.
one hand raised, Ranji
Okay,
George. Ranji,
okay.
you have about 1 minute and 34 seconds left.
Go ahead, Ranji. Go ahead with your comment, please.
Yes. This is Ranji Jha. Thank you. Thank you, Chairman and the staff, for putting up this great presentation. Even the last one was terrific. This is a very useful technology because waste heat is where we lose a lot of the efficiency in combustion. Almost 70% lost in waste heat in most forms of combustion. So thank you for utilizing this waste heat for running your processes. I have 3 quick questions. One is the NOx ppm was calculated without using the combustion material, right? It's separate from it. That's why it's so low, because if you include the combustion, the NOx will be higher. Secondly, what is the threshold of heat you need to make it efficient? The higher the heat, probably the more efficient it is, the lower. So is there a threshold? So it may not be applicable to across the board, but in some application than others. Thirdly, what's the reliability? Have you looked at how long it will run, and have you done various quality measures to give us that answer? Thank you.
Thank you, Ranji. Before we answer those questions, do we have any other public comment?
No additional hands are raised.
Okay, we'll go ahead and close public comment, and then just if you'd like to respond to any of those comments, feel free.
All right, I'll take the first one very easily. The NOx and ppm question, that's actually coming out of our exhaust stream. So that is all things considered coming out of the exit exhaust stream. That's single digits parts per million with no after treatment systems.
Thank you. Any other comments before we conclude?
I think I just wanted one more time to say thank you to South Coast AQMD. We really appreciate the opportunity to share with you what we have coming to the market right now, and looking forward to sharing with you in the future some of the successes we have.
Thank you for taking the time for the report. We'll look forward to exploring opportunities for future collaboration and having you back for an update in the future. So our best to you. Keep up the good work.
Thank you so much.
Okay, thank you.